Folks, hello and welcome to your Week 4 discussion post. We're almost halfway through the course, and I know everybody's excited about that, so let's get on with this week's discussion post. First off, make sure that everybody has their calculus identification number ready. It looks like this week you'll only need the A digit, so a pretty simple substitution for you this week. I'm going to read through this. I'm going to read through the statement of your problem. I'll highlight a couple things, and then we'll read back through it again without any of my commentary. But it says, at which points are the tangents, and notice that tangents is plural, drawn to the ellipse x squared plus y squared equals ax plus ay. So a is shown there in braces, and that will be the substitution of your A digit from your calculus identification number as both the coefficient for x and y. Parallel to the x-axis, round the coordinates to two decimal places, verify your solution graphically. So at which points are the tangents drawn to the ellipse x squared plus y squared equals ax plus ay parallel to the x-axis, and you're going to round those points to two decimal places. And we're also very similar to what we've done in a previous discussion post. You're going to verify this solution graphically. As I mentioned, let's just mention that in a recent post we did do something very similar where we had a graph. It looked almost parabolic in nature, and when you found the point on the graph where the slope of the tangent line was equal to 0, you were able to kind of corroborate graphically what you had done computationally. And we're going to do something very similar this week, only using an ellipse. And let me say that a circle is a special type of ellipse, so you may just find that this, when you graph it, that you are actually dealing with a circle. So no, I really just this week, I'm not showing any equations or notation. I'm just going to offer up some steps here for you to go through and finish up this discussion post. So my first, sorry about that, my first comment to you here, first note is we want to start by writing the equation x squared plus y squared equals ax plus ay by subbing your value of a as both the coefficient of x and y on the right-hand side of the equation. So that would be the first step. So go ahead and write that equation. Secondly, when we start talking about slopes of tangent lines being 0 and finding those points, obviously we're again talking about an application of the first derivative of this equation. What you notice from this equation, it's not written in a nice form where you have either f of x equals or y equals. And so the way that you're going to differentiate this is you're going to differentiate it implicitly, and that's what we've done this week in our lesson. And again, that assumes that the variable y here simply represents a function of x. So you see it both on the left and right side of the equation. So you'll be differentiating this implicitly in this term as well. Notice I also add another note here that this is going to require a chain rule, and the chain rule will come in on this term right here. So when you differentiate y squared and you differentiate it implicitly, you know that by the product rule that the derivative becomes 2y, and then by the chain rule and the fact that y is a function of x, you'll have y prime. So just as a little hint here, when you differentiate this term, you should have 2y times y prime. And you'll also have another situation here where you're going to have another y prime. So the first two steps will get you to the point where you have taken the derivative implicitly. In the next step, I say on the in the left and right side of the equality, you will have a term in y prime. So remember I mentioned that once you differentiate here and differentiate here, you'll have terms involving y prime. So we want to move both of those terms to one side of the equation or the other. And then in the next step, once you have those two terms involving y prime on one side of the equation or the other, you can solve for y prime. You'll see that y prime essentially acts as a common factor. And once you go ahead and simplify this and set y prime equals something, you're going to end up with a rational expression, and the variable term in the numerator will involve x. I should say you actually end up with a binomial in the numerator with a variable of x. So once you have found that derivative, you're going to take that derivative, you're going to set it equal to 0. The only time that rational expression is going to be 0 is when the numerator itself is equal to 0. So take the numerator, set it equal to 0, and solve for x. At that point, what you're going to want to do is then jump to the graphical solution. As I reminded you last time, if you go into the modules section of the course and scroll down to the course-specific requirements block, you'll find a couple of options for graphical calculators there. So go ahead and fire one of those up and graph this equation with your value of a sub for x. For a as the coefficient of x and the coefficient of y. Obviously, since this is an ellipse or a circle, which again, a circle is a special case of an ellipse, obviously there'll be 2 points on the graph where tangent lines are parallel to the x-axis, and those points that you see here visually should match up with what you have done here computationally. So there should be good corroboration between the final computational step and the graphical step, and so that should make very good sense once you look at it in both in the numerical and in the graphical. To finish this up, as we always do, let's talk very quickly about your rubric. Again, I'm looking for a real good attempt on the first submission. Make sure it's very clear, and make sure you have submitted your graph along with your computational work. If there is anything that is missing in your post, I will give you that feedback within 24 hours. And please look at my feedback and go ahead and finish that up for me. And then make sure you're using an equation editor so that the work is done neatly and it's done professionally. And make sure you submit that along with your graph as well. And so I think we're pretty straightforward on this discussion this week. Again, the idea is understanding implicit differentiation, and I hope the hints I gave you above make this pretty straightforward for you to finish this up. So looking forward to seeing a lot of good posts on the discussion board. If you need any help, let me know, and take care and enjoy the rest of your week.